This video is just going to go over the test that we just took for Unit A. You can fast forward to the problems you have questions about and take a look at those. This can also help as you're reviewing for the final to take a look at this test. So, let's see how it went. This first test started with graphing of linear equations, asking to graph 3x minus 4y equals 12. First, it has to be solved for y in order to solve it. So I'm going to subtract 3x from both sides. That'll give us negative 4y equals negative 3x plus 12. Now, we can't have anything in front of y, so we'll divide each term by negative 4. And when we do, we'll end up with y equals a positive 3/4 x minus 3. And if I think about y equals mx plus b, my y-intercept is at negative 3 on the y-axis. And then my slope is 3/4, so I'm going to rise 3 and run 4 to get my next point. And then we just have to connect the dots to get our line. Problem number 2 then gives us 2 points, and we have to find the equation of the line. To do that, we first need to know what the slope is. Slope we find by y2 minus y1 over x2 minus x1. So we have our first point and our second point, an x and a y, an x and a y. So y from the second point is negative 5 minus 1 over x from the second point is 2 minus a negative 2. And negative 5 minus 1 is negative 6. When we do the two negatives making a positive, 2 plus 2 is 4, which reduces to negative 3/2 for our slope. To find our y-intercept, we think about y equals mx plus b. We'll use the slope we just found and either one of the 2 points. I'm just going to use the first point. So y is 1, m is negative 3/2. X is negative 2 plus b. Reducing negative 2 over 2 is negative 1. So we have 1 equals negative 3 times negative 1 is positive 3 plus b. Subtract 3 from both sides. And negative 2 equals b. This means our final equation is y equals m negative 3/2 x minus 2. For number 3, we're asked to solve a system of equations. The systems of equations that we're asked to solve, probably best to use the elimination addition method. This really sets up next unit with matrices quite well. We can either get rid of the x's or the y's. I'm going to get rid of the x's by multiplying the first equation by 3 and the second equation by negative 2. Negative 2. So when we do that, we'll get opposites in front of the x's. That's going to be 6x minus 9y equals 12. And negative 6x plus 8y equals negative 10. And when we add those together, we get negative y equals 2. And dividing by negative 1, y equals negative 2. To find x, we go back to either original equation. It doesn't matter which. I'm going to go to the first equation. 2x minus 3y. Y we now know is negative 2 equals 4. Multiplying, we get 2x plus 6 equals 4. So we subtract 6 from both sides. 2x equals negative 2. Divide by 2, and x equals negative 1. So for our xy, it's negative 1, negative 2. Problem number 4, similar problem to number 2 actually. We just need to make an equation based on some points that are given to us. Now, one way to do this is say in 1985 sales were 36,000. And in 2005, sales were 76,000. And you can go through all the work with those big numbers, and you'll get the same exact final answer that I'm going to get, but I want to do it with some smaller, nicer numbers. Instead, we're going to call 1985 year 0, which means 2005 is 20 years later, so I'm going to call that year 20. So in year 0, the total was $36,000. And I'm just going to know my y is in thousands. I'm just going to use 36. My y otherwise is going to be 76. So 20, 76. These numbers are going to be easier to work with as we make our equation. First, the slope, not using the big numbers, is 36 minus 76 over 0 minus 20. That's going to give us negative 40 over negative 20, which reduces to 2. Another nice thing is we already know the y-intercept, because the y-intercept is always 0, b. And since we have a 0 for our first point, 36 must be the y-intercept. So my equation now is y equals 2x plus 36. Now that we have our equation, we're going to use our equation to predict sales in 2000. 2000 is 15 years after 1985, so we're going to plug 15 in for x. Y equals 2 times 15 plus 36. That's going to be 30 plus 36, which is 66. Remembering that's in thousands, so there are $66,000 in sales. Number 5 is asking us to find an equation for cost and revenue. So first with cost, the fixed costs are the unchanging cost. That's always our y-intercept. The variable cost tells us how things are changing, the rate of change. That's our slope. So our equation for cost is y equals m, the variable cost, times x, plus b, the fixed cost of 25,000. Revenue, that's how much money comes in. The widgets sell for $80 per widget. That's our rate of change. That's our m. And we bring in no revenue if there are no sales. So we just have a slope, no y-intercept, y equals 80x. The equilibrium point, the break-even point, then, is when these two equations both equal each other. So we'd have 60x plus 25,000 equals 80x. Subtracting 60x from both sides, we get 25,000 equals 20x. Divide both sides by 20, and x equals 1,250 widgets for our equilibrium break-even point. From here, we moved on to the financial math problems. Problem number 1 is an investment of $2,000. It's a one-time lump sum investment. The lump sum investment is A equals P times 1 plus R over N to the NT. $2,000 is the present value. The interest rate is 0.065, compounded monthly, so N equals 12, and time is the 6 years. So we have A equals P, the $2,000, times 1 plus R, 0.065, over N, which is 12, to the NT, 12 times 7. And if you put that in your calculator, the future accumulated value is $3,148.48. Problem number 2 is a slightly different situation because we're placing $100 per month into an account. This is an investment. It is an annuity. The future value of the annuity is equal to the regular payment times 1 plus r over n to the nt minus 1 all over r over n. So the $100, that's the regular payment. The 11% is the interest rate. And 35 years is the time. And it's per month, so n equals 12. So the future accumulated value is $100 times 1 plus 0.11 divided by 12 to the 12 times 35 minus 1 all over 0.11 divided by 12. Put that into your calculator, and after 35 years, in the account is $492,829.64. Problem number 3 then, took a look at the other type of problem. This is a loan problem, which means it is going to be the P times 1 plus r over n to the nt equals the regular payment times 1 plus r over n to the nt minus 1 all over r over n. The $15,000, that's the present value of the loan. It is going to be at an interest rate of 0.023 for a time of 5 years, and we're looking for the monthly payment, so n equals 12. So this gives us 15,000 times 1 plus 0.023 over 12 to the 12 times 5 equals the monthly payment we're looking for times 1 plus 0.023 divided by 12 to the 12 times 5 minus 1 all over 0.023 over 12. Putting the left side into the calculator, you get about 16,826.25 equals, putting the right side in the calculator, you get about 63.52 m. Doing a little more accuracy on your calculator, but this is good enough for our discussion. Divide by 63.52, and m, the monthly payment, is $264.89. And so in problem 4, you decide, yeah, I want to buy that car. So you're 3 years into the loan. That means the amount of time left on the loan is 2 years. It was a 5-year loan. You're 3 years into it. Time is 2 then, the remaining amount of time. Same exact formula. This time we're solving for a different value. P times 1 plus r over n to the nt equals the regular payment times 1 plus r over n to the nt minus 1 all over r over n. This time we're looking for the present value of the loan. We know the monthly payment. We have all the same variables we had before, but this time we're looking for the principal, or the present value of the loan. Times 1 plus the interest rate is still 0.023 over 12 to the 12 times, there are 2 years left on the loan, equals the regular payment that we just found in number 3 was $264.89 times 1 plus 0.023 over 12 to the 12 times 2 years left on the loan minus 1 all over 0.023 divided by 12. Putting the left side on the calculator, you get about 1.05 times the present value. Now, when you do this on your calculator, you're going to have to do a little bit more accuracy than that, or you're going to be off. But for the sake of our discussion, I'll just do 2 decimals. Equals, putting the right side in the calculator, you get 6499.47. So if we divide both sides by 1.05, we find the present value of the loan after 3 years is $6,207.55. One more problem then. The bond problem. And this is the problem I think that was missed the most on the test. So let's take a look at it. With the bond, there's two parts. There is the lump sum, and there's the payments. So looking at the lump sum will use the lump sum formula that, actually the formula I think is A equals P times 1 plus R over N to the NT, and we are solving for the present value of the lump sum. So A, the future accumulated value, the bond is worth $1,000, equals X, that's what we're looking for, the present value of the lump sum, times 1 plus R, the interest rate of this problem is 0.055, divided by N, it's every 6 months, so we have to divide by 2, it's twice a year, to the 2 times time, it's a 10-year bond. Putting this in the calculator then, we get 1,000 equals, the left side in the calculator comes out to 1.7 approximately, times X. Again, more accuracy on your calculator, but when we divide both sides by 1.7, we get X. The lump sum is worth $581.25. So, the second half of the problem is those payments. We are getting $40 every 6 months, and those payments are paying down a loan. It is a loan formula, which is P times 1 plus R over N to the NT equals the regular payment times 1 plus R over N to the NT minus 1 all over R over N. And so when we plug in, we're looking for, again, the present value of the payments. That's what we're looking for. I'll call that Y times 1 plus R, which is 0.055, over N, which is 2, to the 2 times 10, equals the monthly payment of $40, I'm sorry, the regular payment of $40, times 1 plus 0.055 over 2, to the 2 times 10 minus 1, all over R, which is 0.055 over N, which is 2. Plugging in the calculator, the left side again is 1.7, this time times Y, equals the right side, which is approximately 1047.90. Divide both sides by 1.7, and Y, the present value of the payments, is $609.09. So in order to get the fair market value of the loan, we simply need to add the lump sum and the payment present values together. And I'm running out of room, but when we add those together, 581.25 plus 609.09, we get a present value of $1,190.34. So hopefully that helped answer your questions on the test. If you have any more, bring them to class. Stop by my office. Ready for the next unit.